Okay, so the other issue that we were having with the model is you can see here this very gradual kind of tail off of the recovered population. Um, but the but as we said before, the by day 18, so 18 days after you've been exposed, you should be recovered. And so if we look over at the recovered population here, by day 33, you've got no new infections. So by day um, whoops, by day 50, everyone should be recovered, and you should see no more change in recovered. So which column is recovered? P and Q. So recovered population, number recovered is P. So after day 50, you should see no change in the number recovered because everyone that was infected has had 18 days of quarantine. They're all recovered. But because the way recovery is calculated, you can see here it's multiplying. Well, actually, I'm going to go further up here so you can see I'm recovered. Okay, so it's a multiplying. Sorry, it's dividing the infected population by 18. So essentially, 1/18 of the population recovers every day. But the issue with that is when you have a quarantine and nobody's exposed to the virus, 18 days later, everyone should be recovered. But because it's continually 1/18 of the infected population, it's this gradual asymptotic curve. So that should not be happening. um, so I'm going to fix it in a way that's a little bit imperfect itself, but it'll get us closer, I think, to the results we want. So I'm just going to highlight this because the way I'm going to do this is kind of funky. But okay, so for number recovered, where's that? 18. Okay. So at day 17 here, I'm going to, again, cut that out. So I'm going to use another if statement here. So if the sum, so I'm going to do a sum as well, of the previous 18 days, and that's 18 selected, equals 0, then I want it to equal the infected population, else, and that's my original statement. And I'll explain what this is doing in a second. So close parenthesis, I believe that's correct. Okay, and then copy this, or paste that in by double clicking. So let's see here if it worked, and then I'll explain. Oh, yeah, I made a mistake. Okay, so we have a negative number here, so I made a mistake there because I did not subtract the dead population. Let's see. So this is going to be R, so minus S23 and minus R23. Oops, R23 minus S23. Redo that. Should have got rid of our negatives. Yep, okay. So what was happening is I was double counting the dead ICU, not dead ICU. Okay, so what this is doing, and you'll be clear to see it here, it's summing up the previous 18 days. So it's saying, or it's looking here to see if there are zeros, and zeros here mean that it's 18 days of quarantine. So if you've had 18 days of quarantine, everyone should be moving from the sick population to the recovered population. So if you have the sum of these rows is 18, then everyone left in this sick population, this 923,000, is going to move into the recovered population. And it's a little bit of an odd thing because it's a very steep curve, but it's a way to get that population to move in quickly. So you see here now there's no one else recovering, and so your recovered population is steady. So 18 days after 18 days of quarantine moves everyone, stabilizes everyone who is susceptible because no one else is being exposed, and 18 days later no one is sick because during those 18 days people were recovering. And by doing this weird workaround, that's the way we get to have everyone move into the recovered population. Okay, and I didn't do it past here because past P23. I didn't do it for these rows because it would create a problem with this because you'd be referencing words, and then you'd be referencing empty cells, and then you'd be beyond that. So it's kind of a funky workaround. It's not the best, but I'll show you what it looks like here. So here's our infected population, rising, rising, rising. We put in our intervention at day 15, but it wasn't an absolute intervention, so we still had some growth. Yeah, there you go. And so let's set this to 1 and see what happens. Yeah, so if we set it to 1, it's got very strong intervention. If we move this to a later date, let's say day 20, you can see how it's less effective. There's such an important growth between day 15 and day 20 that doing a complete intervention later does no good at all. And so if you move this even further, let's say day 40, you had really almost no effect. And let's say you move this to day 60, you intervene. Yeah, you've sort of missed the curve. Okay, effective population. All right, I am going to stop it there, and I'll come back and talk some more.